Welcome to the first of our 2 lessons about the coordinate system. In this tutorial, we're going to look at the Cartesian coordinate system and the polar coordinate system. We're going to explore their relationship. In other words, describe them mathematically. In our next lesson, we're going to learn how to convert data from one coordinate system to the next. Let's begin by creating a simple line. The first coordinate will be 0. Tab to get to the next input field, 0, press Enter to register. Now for the second point of our line, it'll be 3 units in the positive x direction and 4 units in the y direction. Enter. And right-click and Enter to close the line tool. From the origin point at coordinates 0, 0, I moved 3 steps in the positive horizontal or x direction and 4 steps in the positive vertical or y direction. We've just created a line using Cartesian coordinates. Let's pull in a diagram. Here I've got pictured a horizontal axis. This we consider our x-axis. The middle point and to the right are considered positive values. To the left of the middle point are considered negative values. Here's a vertical axis. This we know as the y-axis. Any value on the y-axis that's above the x-axis is considered a positive value. Any value below the x-axis is considered a negative value. This system of organizing points in space is called the Cartesian coordinate system. It's also known as the rectangular coordinate system. In the Cartesian coordinate system, to reference coordinates in space, we use the x, y format. The place where the x and y axes intersect has the coordinate 0, 0. This is known as the origin point, and this is the point from which we measure our coordinates. For example, if I put my point right about here, this coordinate we can call 3, 4. I've moved 3 steps in the positive x direction and 4 steps in the positive y direction. Okay, let's check out another point, this time in the negative x direction. Here's a point with coordinates -7, 10. In other words, I've moved 7 steps in the negative x direction and 10 steps in the positive y direction. Let's take a look at one more point. This point has coordinates of -5, -9. Now let's talk about how to create lines in space using Cartesian coordinates. In this example, my line connects the 2 points -8, 4 and 6, -7. Let's go back to my first example now. In AutoCAD, we created a line between the origin point at 0, 0 and the point at 3, 4. Let's take a look at how to define this line in terms of polar coordinates. In the polar coordinate system, the positive x-axis is 0 degrees. The positive y-axis is 90 degrees. The negative x-axis is at 180 degrees and the negative y-axis at 270 degrees. In the polar coordinate system, we define a point by distance and angle. Here, r represents the distance from the origin point to the point which we created. The theta represents the angle from the horizontal line counterclockwise. Okay, let's check out how we can figure out the values of r and theta. The r² formula is probably the easiest way because, as you see, the line and its relationship to the x or y axis do make a right triangle. Let me take a moment to recap some basic geometry. Pythagorean theorem teaches us that r² equals x² plus y². In other words, the hypotenuse squared equals the opposite side squared plus the adjacent side squared. In our case, the opposite distance is 4 units. The adjacent distance is 3 units. This means that the distance r² equals 3 squared plus 4 squared. r² equals 25, and the square root of 25 is, of course, 5. Basically, our distance, equals 5, and our right triangle here has the ratio 3 to 4 to 5. We have our first polar coordinate, r, the distance, equals 5. Now let's check out the second polar coordinate, the angle. In order to determine this coordinate, we're going to need to pick up some basic trigonometry. In this right triangle, we know the lengths of the opposite and adjacent sides. The opposite leg equals 4, the adjacent leg equals 3. Tangent is the trigonometric function that uses the opposite and adjacent in an equation. The tangent of the angle equals the opposite over the adjacent, or 4/3. In order to find the value of theta, we can use an inverse tangent of both sides. One equation would look like this. Arctangent of tangent theta equals arctangent of 4/3. From here we have that theta equals the arctangent of 4/3. All right, let's return to AutoCAD now and perform this calculation. Let's go to the View tab. Palettes panel. Here's the Quick Calculator tool. Scroll down the calculator to the Scientific section, and let's expand it. Click on the arctangent function. Type our argument within parentheses, 4/3, and press equals or enter. Here's our answer. Theta equals approximately 53 degrees. I'm going to return to my diagram for a moment to review some of the basic mapping between the two types of coordinate systems. And here we can see how the Cartesian and polar systems calculate the coordinates. To review, in the Cartesian system, this point is known as 3, 4. In polar coordinates, this point is known as 5, 53 degrees. Let's get back to our AutoCAD workspace. Okay, I'm going to select the line and left-click on this handle. Currently, we're working in Cartesian coordinates. This point's located at 3 units in the positive x direction and 4 units in the positive y direction. Let's right-click on the Dynamic Input toggle in the status bar, scroll to Settings, click Settings under Pointer Input, and let's switch to Polar Format. Click OK and OK again. Now we have the location of this point displayed in a polar coordinate format, 5, 53 degrees. This concludes our first tutorial about the coordinate system. In our next lesson, we're going to learn how to switch polar coordinates to Cartesian coordinates.